up here you have four different graphs, and they all show different things. The y-axis says speed, the x-axis says time. The question I want you to think of is, which one of these four graphs shows balanced forces? Don't say it out loud, think it in your head. The way that you do a question of this type is look at one axis by itself and talk to yourself. It's a sign of intelligence. Ask yourself what's going on with that line. Hollywood, what's going on with this line?
It's accelerating.
It's accelerating. How do you know?
Because it's speeding up.
It's speeding up. If you look at speed here, it starts at 0 and it ends at around 40, 46. Okay, that's definitely accelerating. Acceleration is what? Speeding up, slowing down, or changing direction. Very good. All right, what's happening with this graph?
It's accelerating.
It's accelerating. What is this acceleration called?
Positive.
Positive. This one.
Negative.
Positive.
Negative.
So this guy is going fast, slow down, fast, slow down, fast, slow down. So is he accelerating?
Yes.
Absolutely. Okay, what about this guy?
He's staying accelerating.
He's negative.
Yeah, he's slowing down.
He's negative accelerating. He's slowing down. He's going from 48 or thereabouts all the way down to 0. What's this guy doing?
He's saying
He's at a
It's
constant.
constant speed. Is he accelerating?
No.
No. Do we know if he's changing direction or not?
No.
No, we don't know. It doesn't tell us that, but we're not going to assume that he is or isn't. All we know is based upon that graph, there's no signs of acceleration. Do you agree?
Yes.
You're right, okay? So for number 1, you're going to, in order to answer a question of this right, you're going to analyze each axis individually. This is what you're writing down. If the speed doesn't change, if you look at the speed and it doesn't change the whole time, then you know that there is no acceleration and that the forces acting on that object are balanced. Okay, let's take a look at number 2. Again, I want you to answer this in your head. I want you to answer it in your head, not out loud. We don't want to make those around you stop thinking. The question says, a change in an object's velocity always indicates what? Now stop. I don't want you guys looking at the answer choices before you thought of something in your head. So answer this without any answer choices. A change in an object's velocity always indicates that. Finish the sentence. Somebody tell me. If I accelerate, if my velocity changes, what's velocity? Speed.
Direction.
Speed with direction. Okay, speed and direction. So if my speed changes, what am I doing? I'm accelerating. So look on these. Is anyone acceleration? Okay. Oh, unbalanced forces cause acceleration, right?
Yeah.
That's your answer. Look at C. Have I taught you anything ever about magnetic forces?
No.
Then don't pick it. That's my next point. If I didn't teach it, don't pick it. Every year kids are like, ooh, this sounds smart, I'm going to choose it. I promise you guys, if you need it to do well on a test, I'm going to teach it to you. If I didn't teach it, don't pick it. The dog? The camera's so awful, it's probably not even going to even pick up the dog. That's why I'm teaching louder than normally. All right, the next thing I would like you to write for that same question is that only unbalanced forces cause acceleration. You will never have an object accelerate that is acted upon by balanced forces. You always have to be unbalanced. Let's take a look at the data table for number 3. The question for number 3 says, if you've graphed all of these, by the way, what axis does distance always go on?
X.
The y or the x?
Y.
Y. What always goes on the x?
Time.
Time, okay? So, distance is on the y, time is on the x. If you graphed all these out, which one would be the steepest? Now, what does steep mean?
The depth.
What is more steep, A or B?
B.
All right. B or C?
C.
C. What you're choosing, Chris, is gradual. This is more gradual a slope than this.
Like a roller coaster.
Okay? Like, the more straight up and down you are, the steeper it is. For example.
Then Mr. Freeze.
Okay? I have 4 lines. C, A, D, and B. Which is the steepest?
C.
C. Which is the most gradual?
B.
B. What is, if these were in a race, who would win?
C.
Who would get second place?
A.
Who would get third place?
D.
And who would get last?
B.
B. Okay? C is the steepest. B is the most gradual. And here the fact is, the steeper the slope of a line, the faster the object. Go ahead and write that down. This is number 3. The steeper the slope of the line, the faster the object.
Is this only going down, right?
What's that?
Like, because if you go, you can't go up a steep. It's hard to go up a steep.
It is hard to go up. But I don't want to say that to people because it has, the steepness has no bearing on where you're traveling. It doesn't tell you where you're traveling. All it is a measurement. So if you get a question that looks like this, and it says, go ahead and tell me which line is going to end up being the steepest, what's a way you can answer this question without graphing it?
You look at the distance.
Just the distance? Here's the distance. What did I tell you about the steepness of the line? The steeper the line, the faster. Fastness is also called speed.
Oh.
Okay? How do you calculate speed?
You divide.
Distance
Distance
divided by
divided by time. You will have to calculate speed on this test. Distance divided by time. So what you're going to do is you're going to calculate speed for each one of these, and then the highest number, the one with the fastest kilometers per hour, or whatever units these are in, will be the steepest line. So real quick in your head, what's 180 divided by 2?
90.
What is 270 divided by 3?
90.
What is 360 divided by 4? All right, try this one. What's 150 divided by 1.5? Okay, if it's 10, then do 10 times 1.5. Does that equal 150?
1,500.
Alan, you are correct. It is 100. So Alan, if that one is 100, and these are all 90, what's the steepest line? That one? The first one? Yeah, the first one would be the steepest line. All right. A straight, flat line. A straight, flat line at flat shows constant speed.
Is that still number 3?
This is number 4. A straight line shows constant speed, but it must be flat.
3.
Now here's something I just want to bring to your attention, because you need to know that the people that are making your tests aren't necessarily experts at what they're making the test for. Your STAR test, for example, is made by thousands of people that sit in an office building with the textbook, and they look at the textbook and then they come up with questions. So there's a chance that some of these questions are wrong. And if you look at this one, the question that it's asking is misleading because there's 2 correct answer choices. The question that it asks is, which one shows constant speed? Which one, in your opinion? There's 2 of them show constant speed. Hollywood.
Graph 4.
Graph 4, absolutely. That is constant. What's another one that shows constant speed?
Graph 1.
Graph 1. That's constant. Which one is the only one that shows acceleration, though?
Graph 1.
Graph
Graph
2.
one.
Graph 1.
Out of these 2, one is accelerating. Which
Graph
one?
one.
Graph 1.
Graph 1. This is accelerating, but out of these 2, and I apologize for that misleading question. This one is doing what?
It's
Decreasing.
decreasing. Wait.
Negative
acceleration. No, it's positive.
It's the distance is shortening as time increases, so this isn't even possible. Okay, so if you want to look at speed, if you want me to prove, no, I said it's impossible, not impossible. Okay, all right, let's look at this one. This is a straight line. Now, let's say if I took any point and I put a point down and I traced it over to the distance and traced it over the time and calculated the speed, if it's a straight line, any point I pick on this entire thing will come up to the same number. Does that make sense?
Yeah.
Okay, let's say that this is 1 and 1. What's my speed? 1 divided by 1 is?
0.
1 goes into 1 time. Okay, this is 2 and this is 2. What's my speed?
1.
This is 1.5 and this is 1.5. What's my speed?
1.
This is 4 and this is 4. What's my speed?
4. 1.
1, 1, 2. Yeah, no. Okay, 4 divided by 4 is still 1. All right, so with anything that is a straight line, if you calculate speed off of it, you're always going to get the same speed. That's why it's constant. But is 0 miles an hour constant?
No.
No.
If I'm traveling 0 miles every hour, is that a constant speed?
Yes.
No,
It is.
You're not driving.
I'm not driving,
But
but
it's
it is
still
a
a
constant
constant
speed. The question didn't say, was I driving? The question asked, is that a constant speed?
Yes.
0 miles an hour is a constant speed. I'm constantly not going anywhere.
You're parked in Walmart.
Parked.
In Walmart.
Parked at Walmart. All right. Here's next is a question I want to talk about. We have 2 different types of potential and kinetic energy. We have gravitational potential energy, and we have elastic potential and kinetic energy. Elastic potential and kinetic energy is exactly what it sounds like. Okay? Number 5. Yeah, number 5. All right. So if I have a rubber band, it has energy. How do I increase the amount of potential energy in that rubber band?
Pull it.
I pull it. So elastic, remember elastic, it's stretchy. So anything stretchy has elastic. Our skin is elastic. In commercials, you probably heard it referred to as elastic. But if I want to increase the potential energy of my rubber band, there's nothing here. It's just my fingers. All right. I pull it back and the potential energy increases. How do I increase the kinetic energy?
You let it go.
I let it go. All right, but with gravity, with gravitational potential energy, how do I increase gravitational potential energy? Bring it higher or
Lower.
Mass.
add mass. Bring it higher or add mass. How do I increase kinetic energy?
Velocity.
Lower.
Lower or
Mass.
add mass. Okay, good. So, for number 5, in order to increase gravitational potential energy, in order to increase that, I have to bring it higher or add mass. That's what you're writing. In order to increase gravitational potential energy, I lift it higher or I add mass. Either one of those will increase the potential energy.
I didn't make it. What was the second? Bring it down.
Bring it up higher or add mass. Okay? Here's one that I like because it's extremely easy for students to get. These are all free body diagrams. I did a very complex looking one. It's very simple. But I did a complex looking one in the center. Alright? So in free body diagrams, we have a body, which is represented as this block, and it could be anything. It could be a car, a truck, you. It could be anything. It's just representative of there's something here. And the arrows indicate which direction force is applied. So, if I'm this, what would you be doing on either side of me? Pushing me or pulling me?
Pulling.
Yeah, you'd be pulling me. Now, what would I be pulled to the left or the right?
No, you would
stay
stay
in the
I would
still.
stay in the middle. So what would my net force be?
0.
0. If the net force is 0, the object is balanced. Write that down. If the net force is 0, the object is balanced. For number 6. If net force is 0, the object is balanced.
The what? The object is balanced.
Object is the forces are balanced. If net force is 0, the object is not moving. Or it's moving at a constant speed.
Like when somebody's flying over you.
Yeah, I have that problem. Alright, let's look at C. Which direction is this going to go?
Left.
It's going to go to your left, my right. And by how much?
5.
5. Look at this one. Where's it going?
Right.
It's gonna go to your right, my left. By how much?
5.
5. What about this one?
Stay still.
It stays still. What we want to say is there's a constant speed. This could have been moving at 5,000 miles per hour in space, and then they show 5 and 5, and that means it's still balanced. Okay, you could be moving and still be balanced. Remember that, as long as you're not accelerating. Whenever I have a bigger number on one side, this is showing acceleration, right? Because it's going to move from 0 to something. It's going to go some speed. Take a look at this one. Alright, you do the same thing we've always done. You look at the opposite side. So the opposite of your left would be my right. Would be your right, right? So the opposite of this is that. Do you follow me?
No.
The opposite of this direction is that direction. We're working with opposites today.
Like
left. You get it? Yes. The opposite of left is right. You get it? So do we need to do like black? The opposite of black is white. Now we're making progress. All right. The opposite of up is down. Okay. So all you do is you go for opposing sides. What is this? Are these arrows pointing in the same direction or opposite direction?
Same.
So you do what?
Add.
You add. So what's on this side?
22.
22. All right. Let's go to the opposite side.
10.
All right. We have 7 and 3. So what's my force?
10.
So who's gonna win?
The left
The
side.
left
That
side.
side by how much?
12.
By 12. All right. Hollywood. Slow down. Let other people try. All right. What about this one? 8. What is the opposite of the top?
Down.
The bottom. So 8 versus 3. Who's gonna win?
8.
8 by how much?
5.
All right, so if 8 won, that means it's going to go down, but at the same time, 12 won, right? 12 total on this side, so it's going to go that way. So if I'm going that way and that way on the same time, I'm going to head this direction.
Diagonal.
Okay, that one will not be on your test, but if you know how to do it, you'll get it right. Yes?
What if like the side one of those is not going the same direction? Like one of those.
Oh, if you had arrow, like if you had this one pointed this way and this one's also pointed this way?
Like two arrows on each one, and the one is not like the same as the other one.
Oh, so there's one pointed this way at the same time as this way?
And then the other side it has its two same pointed at one. Like,
You would subtract. You subtract the differences. All right. So you have add them up. Still, you're not going to have one like that. Were you just trying to think of something that would confuse you, or you saw that before?
no, I was trying to think something.
Ah, okay. Don't confuse yourself because we won't do that to you. In no grade will they do that to you. But you would subtract. The arrows are on this side and they're opposite. So I'm going to subtract, and then you follow the exact same steps. You can never have a negative force. You can never have a negative net force.
So they're always going to be positive.
They're always going to be a positive number. How would I apply a negative force to you? Teach me, because I don't know. No, that's still, that's nothing still, okay?
You know how like this, like, look, you go.
You're still applying a force. All right, guys, I tutor after school if you want to come.